I'm Renee Williams.
And I'm Billy Thomas.
And welcome to another edition of From the Woods Today. Billy, a lot of times you'll sit there and you'll think, how does that bird fly? What is a bird? How does this go? It's like I've had these questions, but I've never really dug into it, I guess. But today we were going to have some answers.
Yeah, I'm really excited. We've got a brand new guest. I'm Dr. DJ McNeil, who is a new faculty member here at the UK Department of Forestry and Natural Resources. And he teaches a lot of bird classes and ornithology, and he's a wildlife guy. So he has prepared a presentation for us on what is a bird. So I think you're going to really enjoy that. I've seen some of DJ's lectures before, and they're really entertaining and very informative. So looking forward to that. Appreciate that. We also have the tree of the week this week. Laurie's got a new tree of the week for us. We're looking forward to that one. This is actually one that gets really, really big, Renee. Talking about trees that can get big. This one is one that can really do it. So we'll save that until Laurie gets there. And then if we've got time, we've got a couple of short videos from Megan Buland on different mushrooms that you might encounter out in the woods. So glad to have you all with us today. If you have any questions, please use the chat function and we'll interact with you. And if you're on YouTube, nice seeing you there as well.
Definitely. So I guess we'll go ahead and get started with our What is a Bird segment.
Yeah, and as we mentioned, Dr. McNeil could not be here today. He is actually teaching class this very second to our students. But he did prepare this lecture just the other day for us. So here we go with What is a Bird.
Okay, wonderful. Well, I'm thrilled to be here today talking to you folks about what is a bird, a very interesting topic near and dear to my own heart. And we'll just dive right into it, shall we? So first, before we dive into what is a bird, where birds came from, the diversity of birds in Kentucky and more broadly, it's helpful to have a few basic definitions. So what even is a bird? I think most folks have a very intuitive sense for what a bird is. You've probably seen a bird today, perhaps even eaten a bird today. They're ubiquitous in a lot of ways, but it's helpful to have some basic definitions. So all extant birds that we have on Earth today are warm-blooded. They're all vertebrates, of course, meaning that they have a spine. Birds are all characterized by feathers in some capacity. No species of bird has hair. There are some birds that have hair-like feathers, but feathers are a bird characteristic, at least in terms of contemporary vertebrates. They have toothless beaked jaws. So we know that birds have beaks, and not a single extant bird has teeth. Birds lay eggs, of course. No species of bird gives live birth. They have very high metabolic rates, higher than many other vertebrates. That keeps them warm, that keeps them active. They have a four-chambered heart. They have a highly pneumatized skeleton. Now, that's a sort of fancy term for having hollow bones. So most bird species, we'll talk about some exceptions, have hollow bones, which is an adaptation for flight, and birds are found on all continents. So that's kind of the basic summary of what a bird is, but how did we even get here to have birds the way they are today? Well, when we think about vertebrate animals today a little bit more broadly, we tend to think of five main groups of vertebrates. Now, things can get a little bit hairy when you dive into fish, which we're not going to do, not much anyway. But the five main groups that we think of today are amphibians, birds, fish, mammals, and reptiles. So with those five main groups in mind, we can think of where those groups of vertebrates originated. Right now, vertebrates, of course, these are only animals with spines. They're not going to include things like crabs or octopus or insects, things like that. So we've got these five main groups of vertebrate animals, and we can plot them out on what's called a cladogram or a phylogenetic tree. So we can see the relationships among these organisms. And I know that this is a little bit technical, but I think it's helpful, and I've got pictures and things that'll help us understand this. So, okay, we've got fish. So fish are kind of their own little group. There are some different kinds of fish that, again, sort of make things complicated, but fish form a single monophyletic group. They all share a single common ancestor at some point or another. Amphibians, again, there's nothing really strange going on here. At least to my knowledge, amphibians are a single monophyletic group. And again, mammals, by and large, a similar kind of thing. Now, if you look at what we have remaining, the turtles, the tuataras, which are somewhat these lizard-like reptiles, squamates, which are snakes and lizards, crocodilians, which I think speaks for itself, and birds. And the situation is a little bit more hairy when it comes to birds. And the reason I say that is because frequently birds are classified as their own group, and turtles, tuataras, squamates, and crocodilians are their own group called the reptiles. But you can see that that's problematic based on this phylogenetic tree, because birds are actually sandwiched within reptiles as what we call a sister group to crocodilians. So that presents an interesting problem in the taxonomy of birds and vertebrates more broadly, because reptiles, as we currently think of them, are what we call a paraphyletic group. So that means there's a little bit of messiness in there because we are classifying it as a single group while excluding one monophyletic clade that's sandwiched within it, that being the birds. So we call crocodilians reptiles, but we call birds birds, when in reality, birds either should be reptiles or crocodilians should be birds. And I'll talk a little bit more about why that is. So this is that same tree that we just looked at here. What we're going to do is we're going to dive into this little bit right here that I've got circled in blue with crocodilians and birds to better understand the origin of birds. So the group that includes crocodilians and birds, and I think I'm going to move this window here because it looks like birds are covered up. The group that includes crocodilians and birds are all called the archosaurs, or the ruling reptiles. So the archosaurs evolved about 240 million years ago, where we've got crocodilians, we've got pterosaurs, your pterodactyls, you've got these horned dinosaurs like triceratops, and sort of the armored ones like stegosaurus, the long-necked sauropods, and then the other theropod dinosaurs, which includes birds and things like tyrannosaurus. So that's the whole group called archosaurs. So archosaurs are the group of reptiles within which crocodilians and birds both fall together. Now, birds and other dinosaurs split apart about 160 million years ago from a group that we now call the theropods. So theropod dinosaurs, they split apart about 160 million years ago. It includes things like birds, but also like Tyrannosaurus, Carnosaura, etc. So, and one of the first inklings that we had in the scientific community that this might be the case was the discovery of a bird-like dinosaur called Archaeopteryx. And that's a very long, fancy word, but it's actually a very fun one. So we're all familiar with, or at least many of us are familiar with the prefix archae, like archaeology. So archae refers to studying ancient things. So archae is ancient, and the pteryx with the silent P, you can think of like pterodactyl, has a silent P at the beginning, PT. Pterodactyl, for instance, means finger wing. So in this case, the ptera means wing. So we've got ancient wing in the Archaeopteryx. And Archaeopteryx was discovered in 1860 as a fossil dating back to 145 million years. Sorry, my screen just went black for a moment there. And what Archaeopteryx was, is it presented a really unusual situation for scientists, because this animal had a combination of both these theropod dinosaur-like traits and modern bird-like traits. It had some of each, right? So it had flight feathers. So it clearly was an animal that could achieve at least some level of flight. It had a fully reversible hallux. Now, that's a fancy term for the hind toe on a bird. Think of a chicken. They've got that one hind toe that can fully reverse to the back. They had very reduced fingers, which is kind of a precursor to the modern avian wing. It had a large fan-shaped tail, much like birds do, and it had a wishbone, just like a bird. But it also had a bunch of dinosaur-like traits, which was interesting. It had unfused metacarpals and metatarsals. These bone and hand, these foot and hand bones were not fused together like they are in a bird. It did not have a keratinized beak like a bird. It had teeth, which of course, as we've already discussed, no birds have. It had a long unfused tail. So you can see that in the illustration. It had a long tail, almost like a lizard or like a Tyrannosaurus, which of course birds don't have. They have a compressed tailbone or several small tailbones. And it had a pelvic structure like a dinosaur, unlike what we see in modern birds. So it had this mix of bird and kind of dinosaur type traits. Now, so that's where we are with respect to the evolution of birds. We saw Archaeopteryx as a kind of intermediate form. That's not to say that birds evolved directly from Archaeopteryx, but Archaeopteryx and birds shared a common ancestor together. And birds split off from other theropod dinosaurs 140 million years ago. But what's interesting is feathers evolved well before that, about 190 million years ago. So this begs a series of questions about why dinosaurs that weren't flying had feathers. So, and we'll talk a little bit about what that is or why that is. We believe feathers are an exception, and I'm going to talk about what that is. A better, more tangible example would be what we see with lungs in fish. So many ancient species of fish, including the modern day lungfishes, had actual lungs, and these lungs are what we call homologous to the lungs of mammals like ourselves, meaning it's essentially the same structure. So we have lungs, lungfish have lungs that perform in very much the same way. Well, of course, if you go out fishing and catch largemouth bass or bluegill, they don't have lungs, right? They're breathing through gills, whereas lungfish can actually breathe air. However, modern fish still have that sac in their body that was historically a lung, but it's no longer used as a lung in most modern fish. It's used as a swim bladder. So it is an adaptation, specifically an exception to maintaining buoyancy. So a fish can expand and contract that lung, that swim bladder, to maintain buoyancy at a certain level of the water column without having to swim around and expend energy doing that. So the fact that we've got the same organ being used for two different things in two different organisms is an example of an exception. So feathers, we believe, are also an exception. So dinosaurs evolved them to do one thing, and modern birds use them, at least in part, to do other things. So some possible reasons that that dinosaurs that are non-avian had feathers, perhaps insulation. So this is kind of the dino fuzz idea that many dinosaurs perhaps were fuzzy to keep themselves warm. Incubation, that's another hypothesis. We've seen fossil evidence that dinosaurs incubated their clutches of eggs. So you can see here on the left a picture of a Canada goose standing over its clutch of eggs that it uses its feathers to incubate. And then on the right, an image of a 150 million year old dinosaur that's in a similar posture, hunkered over its eggs. And of course, sexual selection. This is the idea that maybe that dinosaurs had these feathers, perhaps they were colorful or brightly colored in some way, maybe they were white or whatever, as a means for sexual selection. Maybe that's how a male dinosaur attracted a female dinosaur. Of course, these are all speculation, but potential hypotheses as to why feathers evolved way before flight ever evolved. So where are we today? Well, we've got this same phylogeny here, showing us, or this phylogenetic tree showing us where theropods evolved and archosaurs are. Well, 66 million years ago, we had the Cretaceous Tertiary extinction, which wiped out the vast majority of these. All the theropods were wiped out except for birds. And within archosaurs, birds and crocodilians are the only remaining groups today. So we lost most of the archosaurs due to the Cretaceous Tertiary extinction. And we're not going to talk much more about crocodilians, although bearing in mind that there's been a lot of evolutionary history here. Most of that has been wiped off the earth, now only existing as fossils, with crocodilians and birds being very distantly related groups that are each other's closest relatives today. So at the Cretaceous Tertiary extinction, we had 4 groups of birds that persisted. So we had birds at this time and birds after it. But what we did is we put a big bottleneck. So only a few groups of birds made it through there. So we have the paleonates. So these are things like ostriches and tinamous and some of those groups of birds. The anseriforms, so those are ducks, geese, and swans, and screamers, and some of those others. Galliforms, so those are, of course, chickens, turkeys, any kind of bird that you might describe as fowl or an upland game bird. It's another one that's pretty nice to remember. So gallus means chicken, and form means shape, so shape of a chicken. And then, of course, neoaves. So these are the modern day birds, passerines and others. So again, where does this leave us today? How many groups of birds do we have on, or how many species do we have on Earth? Well, currently on Earth, we have about 10,000 species of birds. Of course, we have major conservation issues with our birds, and we're losing species of birds at an unprecedented rate. But we currently have about 10,000 species of birds. And with those adaptations in mind, some species have kind of walked back some of these adaptations they had. So, for instance, the common loon and other loons, they have a solid skeleton. They don't have that highly pneumatized skeleton we saw in other birds. They have very solid bones, which is a re-adaptation for diving. Also, you have birds like the common merganser. They don't have teeth. So this picture on the right, they don't have teeth, but their bill has developed these like keratinized protrusions that function very similar to teeth. It's almost like they re-evolved their own version of teeth. So we've seen some of that. And bird diversity is incredible today. So on Earth, we've got the smallest species of bird, the Cuban bee hummingbird, only about 2 inches long there on the left. And the largest bird, the ostrich in Africa, which grows to about 9 feet and can be up to 300 pounds or even more at times. So we've got an enormous diversity of sizes. But these are species we don't have in Kentucky, right? So we have in Kentucky also pretty enormous breadth of species. We have our smallest bird, the ruby-throated hummingbird, that little guy on the left, that's the male, of course. And then the trumpeter swan, which can be upwards of 40 pounds at times, quite a large bird. Both species are capable of flight, incredible diversity. We have roughly 250 species of bird in Kentucky, which is, of course, very exciting for me as somebody who studies birds. Some of them in Kentucky, anyway, we have these sort of one-hit wonders. So like the belted kingfisher is the only kingfisher we regularly see here in Kentucky. And the cranes, we basically only have one species, the sandhill crane, although whooping crane, a federally endangered species, does move over and occasionally seen in the state. So some of those groups are one-hit wonders, if you will, and others are extremely diverse. So the perching bird order, or the songbird order, Passeriformis, they constitute more than half of the birds that we have in the state, more than half our 250 species, with some families being super diverse. One of them, called Parulidae, are the warblers. This is a very, very diverse group of songbirds that we can find in Kentucky. So we don't need to dwell on this too much, but it's worth taking a moment to remember how we've gotten to the place that we are with birds. And it's a pretty incredible path. I mean, sometimes it feels a little weird to think of birds as being derived from reptiles, or actually even just being reptiles. But in a sense, that almost makes them more special. I mean, even just today, I haven't had a chance to go out in the field and look for birds today, but I just on my way rushing into the office today, saw many species of birds: American crow, mourning dove, American robin, European starling, house sparrow, northern cardinal, rock dove. And I'm sure without very much effort at all, I could see many more species. And probably you listeners have seen many species of birds today. And I think it's worth just reflecting on the history that we took to get our birds today, and appreciate the diversity of birds that we have on Earth and in Kentucky. And with that, I'll sign off, and looking forward to talking to you all more about birds next time. Thank you.
Thank you, DJ. That was a really interesting presentation. So we got to see how birds evolved over time and learned how we have modern day birds. Pretty interesting history there. A big thanks for DJ for putting that together. We're going to keep the show going. We're going to switch gears from birds to trees. Laurie Thomas was put together another tree of the week for us, and this is a tree that gets really large. It is a eastern cottonwood, and this is a tree that we'll find here in Kentucky, often in the western part of the state, but it can grow in other areas as well. So let's take a look at the eastern cottonwood.
I'm Laurie Thomas with the University of Kentucky Forestry and Natural Resources Extension, and I'm here with the tree of the week, the eastern cottonwood. Eastern cottonwood, Populus deltoides, is in the Solaceae or willow and poplar family. Its genus Populus includes aspens, cottonwoods, and other poplars and consists of about 40 species that are widely distributed throughout the northern hemisphere. Eastern cottonwood is also known as eastern poplar and necklace poplar. It is a medium-sized to large deciduous tree that grows 80 to 100 feet tall and 3 to 4 feet in diameter. Open-grown trees tend to have a large spreading crown that is supported by a massive trunk. It is a fast-growing tree. 2-year-old trees can be as tall as 30 feet. Eastern cottonwood is short-lived species that peaks around 45 years and starts to deteriorate around 70 years, and maximum lifespan has been estimated at about 200 years. It is an important wildlife tree, especially in the plains area. Eastern cottonwood is found from the Rocky Mountains to the southern Atlantic coast, but is largely absent from the Northeast and the Appalachian regions. It is found in most parts of Kentucky except for the southeast and the eastern regions. It is commonly found growing in moist alluvial soils throughout the plains and prairie states, usually along streams or watercourses. In the Mississippi Valley on moist alluvial soils, it grows exceedingly fast. It is considered a bottomland species that is commonly found growing with American sycamore, American elm, and black willow. It may also be found on moist oldfield sites with sweet gum. Eastern cottonwood is classified as very shade intolerant. Eastern cottonwood is a deciduous tree with simple, alternately arranged leaves, as you can see in the photo. The leaves are 3 to 6 inches long, triangular or deltoid in shape. The margins of the leaves are crenate to serrate, and the leaves are pinnately veined, like a feather. The leaf petiole is flattened, and there are small glands present at the top of the petiole. The surface is a lustrous green, and the underside is somewhat paler. In fall, leaf color is yellow to golden. This species is dioecious, meaning there are male trees and female trees. The male and female flowers are in loose drooping catkins, and they appear before the leaves emerge. The male flowers are reddish and more conspicuous than the female flowers, and they tend to flower at least a couple of days before the female flowers. The flowers are wind-pollinated. The fruit is a cottony seed borne in a dehiscent capsule. Typically, there are 30 to 60 seeds per capsule, and the capsules are on short stalks on long catkins. An eastern cottonwood is a prolific seeder. Trees can produce millions of seeds per year. Seeds mature over the spring and summer and are dispersed from June throughout late July, depending on location. The seeds are wind dispersed, and the cotton attached to the seed aids in their dispersal. They are also dispersed by water if the tree is located near a water body. Trees can begin seed production as early as 5 to 10 years. An eastern cottonwood is also capable of vegetative reproduction through stump sprouting. The bark is gray to yellowish green on young trees, and as the tree ages, the bark develops thick ridges and deep furrows, and it turns grayish in color. Eastern cottonwood is generally considered a low-value wood that is often used for utility purposes. It is lightweight and relatively soft. The heartwood is light brown and the sapwood is pale yellow to nearly white, but there isn't always a clear demarcation between sapwood and heartwood. It is rated as non-durable and is also susceptible to insect attack. The wood is used for boxes, crates, plywood, pulpwood, and other utility purposes, and occasionally its burls can be used for turning bowls. Eastern cottonwood is important to wildlife, especially in the plains area. Many species use cottonwood as habitat for shelter and nesting, especially along riparian areas, including bobwhite, grouse, hawks, eagles, and other songbirds. Trees, especially young trees, are important browse material for deer, rabbit, and mice, and beaver use the saplings and the pole-sized trees for food and dam construction. Additionally, it is the larval host plant for the eastern tiger swallowtail and the red-spotted purple butterfly. The national champion eastern cottonwood as of 2022 is in Sheridan, Kansas. It is 451 inches in circumference, 70 feet tall, with a 148-foot crown spread. The Kentucky champion eastern cottonwood is in Warren County. It is 281 inches in circumference, 128 feet tall, and it has an 82-foot crown spread. If you'd like to know more about champion trees, check out American Forest National Champion Trees and check out the Kentucky Division of Forestry Champion Trees. Now for a few fun facts about eastern cottonwood. The common name of cottonwood comes from the cotton-like strands that accompany the tree's seed in the spring. The other common name, necklace poplar, refers to the long, narrow seed capsules that look like a string of beads. Eastern cottonwood is the state tree of Kansas, Nebraska, and Wyoming. It is sometimes called the pioneer of the prairie because pioneers on the Oregon Trail would look for such trees for their shade and firewood, and their presence usually meant water was nearby. The oldest eastern cottonwood was the Balmville tree of Balmville, New York, which was estimated to be 316 years old at the time it was felled in 2015. Populus is the Latin common name for this tree, and its epithet deltoides refers to the shape of the leaf, which is triangular or deltoid in shape. I hope you get the opportunity to get out into your woodland, a local park, or neighborhood and appreciate the trees of Kentucky, including the eastern cottonwood.
Thank you, Laurie. That was a really good presentation on the eastern cottonwood. I had no idea it could live over 300 years. Very interesting indeed. A big thanks to Laurie for putting that together for us. So we've learned about birds. Now we've learned about the eastern cottonwood. Let's keep our discovery going, if we will. We have a couple of short videos from Megan Buland. She's found some mushrooms that you all might see out in the woods. So let's turn it over to Megan now.
This is Ganoderma applanatum. It's sometimes called the artist conch fungus or the artist shelf fungus, and we'll get to why in just a moment. But these fungi are really sweet wood decaying fungi from the genus Ganoderma. It's a fairly good sized genus in our area with some really distinctive members, including this guy. They have a shelf-like woody fruiting structure that is very tough. They're not something that easily breaks apart. And they grow on decaying hardwood trees, either as saprophytes or as parasites. They tend to have a brown to buff colored top to the fruiting body, and they can sometimes have a slightly dusty appearance. They may also be more of a light gray color on occasion. It just depends on what they're fruiting on and the age of the specimen. As Ganoderma fungi, they don't have gills on the underside of the fruiting body. They have very, very small pores, and they produce white spores that are released off of the fruiting body and float away in the wind. They're called artist conch fungi because when you bruise them or mark them with any kind of an implement, a pocket knife, a twig, or your fingers, they very readily bruise and have a distinctive darker color underneath. And so people will often use these fungi to create really beautiful, almost scrimshaw style depictions and drawings on the fruiting bodies of these fungi.
This is Geastrum fimbriatum. It is the sessile earth star. These are really beautiful gastromycete fungi. As gastromycetes, all of their spores are inside that fruiting body. There are no gills, no pores, no teeth, nothing like that. The earth star fungi, they start out as a closed kind of globe, and as they start to mature, they open up and these beautiful arms that give them their star name spread out, usually 5 to 9 arms on this species of earth star, and create this beautiful sun or star-like pattern around this central portion of the fruiting body, which is where the spores are held. When it's ready to release its spores, that little ostiole will open and the spores will be able to escape through that structure with wind or raindrops falling on the mushroom. These fungi like to grow on decaying material, on rotting logs, or on the forest floor as saprobes. They're a really fun little group of fungi.
Thank you, Megan. Two really cool mushrooms that you all may see out in the woods. So when you're out there looking around, keep an eye out for those. I remember seeing the artist conch when I was a student, when I first discovered what that was. You often find it on black locust and some other species. So pretty interesting. All right, well, folks, that wraps up our guest for today. A big thanks to DJ McNeil covering What is a Bird. Pretty interesting history there for sure, to see how we got to today's birds. And then we learned about the eastern cottonwood, which is a really cool tree that can grow tremendously large. And then Megan shared a few cool mushrooms that you might see here in the woodlands of Kentucky. We appreciate you all being with us today, and we look forward to seeing you all next week at 11 o'clock on Wednesday. And until then, we hope everyone has a great week.
From the woods today.